All right, so this is solving nonlinear systems day 1. So in Algebra 2 with Trig, in Integrated, in Algebra in middle school, you solved linear systems where you were given 2 equations of 2 lines and you found out where they intersected. Now you could do that graphically by substitution, elimination, or in Algebra 2 with Trig, you also learned matrices. So what we're doing in pre-calc is we're not doing a line and a line. We're going to do a circle and a parabola, or ellipse and a hyperbola, or a line and a circle. We're going to do either 2 quadratics, like a circle and a parabola, or we're going to do a quadratic and a line. So a circle and a line. Okay. Now when you have a quadratic and a quadratic, it's either going to have 0, 1, 2, 3, or 1, 2, 3, 4, or infinitely many solutions, and you're going to use substitute or elimination for that. And if it is a quadratic and a linear system, then it's going to have 0, 1, or 2. 0, 1, or 2. It's hard for me to say those numbers. And you're going to use substitution. So let me explain that really quickly down here, and then we'll get into the actual notes. So if you have 2 quadratics, so 2 quads, okay, meaning anything with that both of them have to have squares in them. So it could be an ellipse and a hyperbola, a circle and a parabola. It could be any combination of those. So let's see when there's 0, 1, 2, 3, 4, or infinitely many solutions so you can see the difference between them. So I'm going to use, for my examples, a circle and a parabola. Those are my 2 quads I'm going to use, my 2 quadratics. So if I have a circle and I have a parabola, draw a parabola, they can intersect 0 times. Not at all, right? So there'd be no solution. If I have a circle and I have a parabola, they can, I'm going to put that back. They can intersect once. So here's my circle, and then my parabola can hit it once, right there, and there'd be 1 solution. I could have a circle and a parabola, and I can hit the circle twice. That would be 2 solutions. If I have a circle and I have a parabola, I could hit it 1, 2, 3 times. There's a parabola. If I have a circle and I have a parabola, they can intersect 4 times. 1, 2, 3, 4. Now, if I have a circle and a parabola, they can't intersect infinitely many times because they're a circle and a parabola are not the same thing. This would have to be the exact same thing. So if I had a circle and the exact same circle, they can intersect infinitely many times, right? But you won't see that in this class. I'm not going to give you the same circle and the same circle. Okay, next, and if you see 2 quadratics, if you're looking at your equation, they both have squares in them, you're going to use elimination. Okay? Now, if you have 1 quadratic and 1 line, you are going to use substitution. And you can have 0, 1, or 2 solutions. So I'm going to use a quadratic and a line. So for my quadratic, I'll use a circle again. So I'll do a circle and a line. Here's them never intersecting. A circle and a line. Here's them intersecting once. Circle and a line. Here's them intersecting twice. 2 solutions. Can't get them to intersect 3 times. And I cannot have them intersect infinitely many times because 1 is a quadratic, 1 is a linear equation. So that's why you have these possibilities. Okay, so once again, if it's 2 quadratics, elimination, 1 quadratic, substitution. All right, so let's look at our first, and that's what it says right here, okay? Let's look at our first example. It says, find the points of intersection of the graph, so solve the system, basically that same thing that means. The first equation is y equals negative x plus 3. The second one is the second one is x squared plus y squared equals 5. And it says solve it algebraically. So I want to use substitution or elimination. So I look and I know that this is a line and the other one, this right here, is a circle. There's an x squared and a y squared. Addition separating, but their coefficients are the same. So if I have a line, I'm going to use substitution. So this is already solved for y. This is what y is the exact same thing as. So what I'm going to do is in this equation, I'm going to substitute in for y negative x plus 3. So I have x squared plus, instead of writing y squared, I'm going to put negative x plus 3 quantity squared equals 5. All right, now I have to solve this. So first thing I want you to realize is that if I ask you what do I do next and you say distribute a square, it's very upsetting because there's no such thing as distributing a square. If you say distribute a square, you think distributing a square means multiply by 2, which it doesn't. Okay, so you do not distribute a square. A square, when you see it, means that that factor appears twice. So that's what you need to do, is you need to write out that factor twice. Okay, so now I can expand this by multiplying it out. A lot of you call that foiling, which I'm absolutely fine with. So first times first is x squared. Outer's negative 3x, inner's negative 3x, that's negative 6x. And then last times last is 9 equals 5. All right, on the left-hand side, I can combine like terms. I have an x squared and an x squared, which is 2x squared. Minus 6x, and then instead of putting plus 9 equals 5, I realize I have a quadratic right now. And when I'm working with quadratics and I want to try to solve them, my first option is by square rooting, which I can't because there's an x squared and an x. My second option is by factoring, but I can only solve by factoring if it's equal to 0. So whenever I realize that it's a quadratic, instead of doing that, I'm going to always say, okay, I need to get it equal to 0, so I'm going to minus 5, and then I'm going to have plus 4 equals 0. All right, now I'm going to try to factor it. So first thing when you factor is you look for a greatest common factor. Do these three terms have anything in common? Yes, they have a 2 in common, so I'm going to factor that out. Then I have x squared minus 3x plus 2 equals 0. Now I need to factor what's left inside right here. All right, so I have 2 times, and then two numbers that multiply to give me 2 and add to give me negative 3 are negative 2 and negative 1. If you need to use your organizational X, you can. You're going to set each factor equal to 0 and solve. I'm only going to set these two equal to 0 because this one doesn't have an x in it. So I get x equals 2 and x equals 1. All right, now those are my x values. Remember, this is where they intersect. They're points. So I only have the x values. I still need the y values. So I have x is 2 and x is 1. Now you have to plug in x. Now you have two different places where you think that you should plug them in, the line and the circle. Don't plug it into the circle. The circle can give you extraneous solutions. It can give you solutions that don't work in the line. So just plug it in the line. That's a little shortcut. Otherwise, if you plug it in the circle, then you have to check it in the line. Okay, I'm going to plug in 2 into the line. Y equals the negative, and then I'm plugging in 2 for x plus 3. So I get y equals 1. So my first ordered pair solution is 2, 1. Next, I'm going to plug in 1. I have y equals negative, and then 1 plus 3. So y equals 2. So my second ordered pair solution is 1, 2. Make sure you put them in the order x, y, not y, x. So these intersect at the point 2, 1 and at 1, 2. All right, next we have find the points of intersection of the graphs y equals x plus 2 and y equals negative x squared plus 4. So first off, this right here is a line, and this right here, y equals negative x squared plus 4, is a parabola. There's just an x squared, there isn't a y squared, so it's a parabola. Let's start off by graphing the line. So I know I have a y-intercept of 2 and a slope of 1. Make sure you put all of your points that are on the graph paper on that line. Like, make sure you define them all, because we're looking for a point of intersection, and if you get your line crooked, then you're not going to be able to tell your point of intersection. Okay, there's my line. All right, now I'm going to graph my parabola. So I need my vertex. Well, first off, which direction is it facing? Down, because it's y equals a negative. Then I need my vertex. My vertex is 0, 4. So I'm going to want to make a table here because I'm going to need my points. 1, 2, 3, 4. And I like to put my vertex right in the middle. So my vertex is 0, 4. Then I'm plugging in x values to get y values. So 1 and 2, and I'll reflect negative 1 and negative 2. Plugging in 1. 1 squared is 1. The opposite of that's negative 1 plus 4 is 3. Then I'll plug in 2. 2 squared is 4. The opposite of that is negative 4 plus 4 is 0. So I have negative 2, 0, negative 1, 3, and then their reflections. So connect those points. And there is my parabola. Now remember, we were looking for the solutions to this system, which is the ordered pair intersection of the intersections. So I'm going to write down my two. I forgot to put arrows on the end of my parabola, and that's bothering me because it's not accurate. Okay, now my two solutions are negative 2, 0 and 1, 3. Okay, the next problem here says solve the system by graphing and algebraically. So let's do it algebraically first. Okay, so you look at it and you have to decide if you're using substitution or elimination. So look to see what you have. Do you have two quadratics or a quadratic and a linear equation? The first one's a quadratic because they're squares. The second one's linear. So you're going to use substitution. So we are going to substitute 2x minus 4 into the first equation, and we're going to replace y with 2x minus 4. So I have 16x squared plus 4 times the quantity of 2x minus 4 and squared equals 64. All right, so now I have to solve this. Remember, please don't distribute the 4 first. You have to take quick care of the exponent, and that means that factor is there twice. So we're going to write it out twice. 16x squared plus 4 times 2x minus 4 times 2x minus 4, and then equals 64. Let's multiply out those two binomials. So you have 16x squared plus 4 times, and now I'm going to multiply out those two binomials. 2x squared times 2x times 2x is 4x squared. 2x times negative 4 is negative 8x. That's outer. Inner is also negative 8x. That's negative 16x. Last, negative 4 times negative 4 is 16 equals 64. All right, now I have to distribute my 4. 16x squared. Distributing your 4. 4 times 4x squared is 16x squared. 4 times negative 16x is negative 64x. 4 times 16 is 64, and then equals 64. All right, left-hand side, combine like terms. That's 32x squared minus 64x. And now, once again, I realize I'm going to have a quadratic that I'm going to want to try to factor, so I'm going to want to get this equal to 0. So I'll get rid of the 64 here, subtract it off of this side, and they cancel. So I just have equals 0. All right, now I need to factor this. Whenever you're factoring, the first thing you're always looking for is a GCF. Do they have anything in common? Yes, they have 32x in common. And then I have x minus 2 equals 0. And now I can set each factor equal to 0 and solve. So I get 2x values. I get, if you divide by 32, divide by 32, you get x equals 0 and x equals 2. Don't box that because that's not what answers look like. They're ordered pair solutions. So I'm going to put lines underneath it instead, and I'm going to say, okay, I need to plug in 0, I need to plug in 2. Where? The quadratic or the line? Always the line. Plug it into the line. So I'm going to do 2 times x minus 4. Y equals 2 times 0 minus 4. Y equals 2 times 0 minus 4 is negative 4. Wow, I don't know why I couldn't do that math in my head. So my first ordered pair solution is x comma y, 0 comma negative 4. Then I need to plug in 2. Y equals 2 times 2 minus 4, and that is 0. So my second order pair solution is 2 comma 0. Okay, so I just solved that algebraically. Now let's do it graphically, okay, to see that we get the same answer. So I need to graph both of these. The first one we already said is a quadratic, but what type of quadratic is it? Is it a parabola, ellipse, a hyperbola, or a circle? So let's look to find out. I'm going to erase this stuff here I used for my algebra. Okay, so if you look at it as an x squared and a y squared, right? So it's an x squared and a y squared, so it's not a parabola. There's addition separating. So now I know it's either a circle or an ellipse. So now I need to look at my lead coefficients. If you look at your lead coefficients, they are different. So that means this is an ellipse. So I'm going to be graphing an ellipse. Okay, I want to decide, is that ellipse vertical or horizontal? I can't do that until it's in standard form. So remember, ellipses are equal to 1. So what I'm going to do is divide everything by 64 so that it's in standard form. So 16 goes into 64 4 times. So that's x squared over 4 plus 4 goes into 64 16 times. So y squared over 16 equals 1. All right, now I can decide if it's vertical or horizontal. Since my second denominator is bigger, I know it's vertical. And now I'm going to graph this vertical ellipse. So I'm going to graph the center, 0, 0. Since it's vertical, I know a squared is 16, so a is 4. So I'm going to go vertically up 4 and down 4. Then I know b squared is 4, so b is 2. So I'm going to go left 2 and right 2. And then I'm going to connect these 4 points. I'm going to connect these 4 points to make my ellipse. I did the best I can do. No, I didn't. I can do better. I can do better. Can't I? Let's try. That's good enough. Okay. There's my vertical ellipse. All right. So do I need to draw foci? No. Why not? Because I want to know where the line hits on this blue part right here that I'm highlighting. Okay. All right, so now let's graph the line. I'll graph the line in a completely different color. Let's graph the line in red. Okay, so I need to graph y equals 2x minus 4. So y-intercept of negative 4. Slope of 2, up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Down 2, left 1. And then I can connect these points to make my line. And then I can confirm that my points of intersection are 2, 0, and 0, negative 4. Boom, boom. Good. Okay. Next one. Solve the system algebraically. Find the points of intersection is the other directions you could see, but I'm going to say solve the system algebraically. All right, so we have to decide to use substitution or elimination. So if you look at them, they're both quadratics. They both have squares, so you're going to use elimination because you don't want them to be quadratics. You want to break them down, okay? All right, so we're going to use elimination. So you're going to look and say, if I combine these right now, will my x's cancel out? X squareds cancel out, I should say. No. Will my y squareds cancel out? No. So what I have to do is I have to manipulate this so one of them will. The easiest manipulation is going to be multiplying the second equation by 4, because then when I do that, it'll become a negative 4y squared, and the y squareds will cancel out. So let's do that. We're going to keep our first equation exactly the same. 9x squared plus 4y squared equals 36. The second one we're going to multiply by 4. 16x squared minus 4y squared equals 64. All right, so now I can combine these in a variable will eliminate. 25x squared is equal to 100. I need to solve this by square rooting, but in order to square root, it has to be x squared by itself. So I have to divide both sides by 25 first. I have x squared is equal to 4, and now I can square it to solve. Remember, whenever you square it to solve, you have to account for the positive and negative value that make the equation true. So I get x equals plus or minus 2. So I get two x values. X equals 2, x equals negative 2. And I have to get the y values for each one. So I need to plug in 2 for x. Doesn't matter which equation I pick. No, because they're both quadratics. So whichever one looks better to you, just use it. I like to use the first one unless one looks simpler to me. So I'm going to do 9 times 2 squared plus 4y squared equals 36. 2 squared is 4. 9 times 4 is 36 plus 4y squared equals 36. I could solve for y by square rooting, but I have to get it by itself first. So now I have 4y squared equals 0, divide by 4, y squared equals 0, square root plus or minus, and I get y equals 0. So that gives me the point 2, 0. All right, now I'm going to plug in -2. So I'm going to do 9 times -2 squared plus 4y squared equals 36. All right, square your -2, which is 4. And now I realize I'm going to multiply and get 36, subtract 36, divide by 4, square root. I'm going to end up getting y equals 0 again. So I don't have to show all that math again. So my second solution is -2, 0. There they are. 2, 0, and -2, 0 are the points of intersection. All right, next one, solve the system algebraically. So first thing I have to do is decide if I'm using substitution or elimination. I have a quadratic and a quadratic, so elimination. So I want one of my variables, one of my squares, I want either x squared or y squared to eliminate. So I look, if I add them right now, will anything eliminate? No, so I have to manipulate it. Well, both of them have an x squared, only the first one has a y squared, so we're going to eliminate x squared. You can multiply either equation by -1, and the x squares will end up canceling out. So I'm going to rewrite my first equation exactly the way it is. I'm going to write it. The second one, I'm going to multiply everything by -1. So I get -x squared plus 2y equals -8. And now I can combine these. When I do that, x squared and -x squared cancel out. Then I have a y squared plus 2y, which is y squared plus 2y. All right, they're not like terms, you can't combine them. Equals 16 and a -8 is 8. All right, so this is a quadratic with a y squared and a y, so I cannot solve by square rooting, but I want to try to solve by factoring that. In order to solve by factoring, it has to be equal to 0. So I'm going to do y squared plus 2y minus 8 equals 0. Is this factorable? Yes. I'm looking for two numbers that multiply to give me -8 and add to give me 2, which are 4 and -2. So I have y plus 4 times y minus 2 equals 0. I get two y values, -4 and 2. All right, now I have to plug in those y values. Y equals -4, y equals 2. All right, doesn't matter which one I plug it into? Nope, because they're both quadratics. So I'll just use the first equation. I'm going to do x squared plus -4 squared equals 16. X squared plus 16 equals 16. X squared equals 0. X equals 0. So I have 0, -4. Oops, I started a box already when I haven't got my other answer. All right, now I need to plug in 2. X squared plus 2 squared equals 16. X squared plus 4 equals 16. Subtract 4. X squared equals 12. Square root plus or minus, square root plus or minus, x equals plus or minus. Root 12 is simplifiable because 4 goes in there 3 times, so 2 root 3. So I get 2 more points from this. I get 2 root 3 comma 2, and I get -2 root 3 comma 2. But most people just end up writing it as plus or minus 2 root 3 comma 2. And you still have 3 solutions, though. All right, next one, solve the system algebraically. All right, so I have to decide if I'm using substitution elimination. So if you look at the first one, it is quadratic. If you look at the second one, it's not a quadratic. So I'm going to use substitution. Now I want to substitute in either x or y, and this equation is not solved for x or y, so I need to solve it for one of them. It does not matter which one. I'm going to solve it for y. So I'm going to divide both by x, and I get y equals 3 over x. And now I can substitute this in for y. So I have x squared plus 3 over x squared equals 10. All right, so now I need to solve this. First thing I need to do is I either need to write this out twice or square my fraction, which means square the numerator, square the denominator. Doesn't matter which one you do. So if you have x squared plus and then 3 over x times 3 over x, you can do that. Or you can just say that's x squared plus 9 over x squared equals 10. Right? You could have said square the 3, square the x. Either one's fine. Okay, now I need to solve this. So though I always ask students, what bothers you about this? Because it's not like, oh yeah, you just do this. And they'll say it's the fraction. If the fraction's bothering you, then you should get rid of it. I can get rid of it by multiplying everything by what's in the denominator. So what I can do is I can multiply this by x squared, multiply this by x squared, multiply this by x squared. It's called multiplying by the LCD. So x squared times x squared is x to the 4th. This becomes 9x squared over x squared. That cancels, so it's just 9, which is what we wanted, equals 10x squared. All right, so this is not a quadratic. It is a quartic function, but with a quartic function, you still want to try to get it equal to 0 so you can factor it. So I need to get everything on one side, so I'm going to subtract 10x squared from both sides. I'll write that second because I want to write it in standard form. So I have x to the 4th minus 10x squared plus 9 equals 0. All right, I want to try to factor this. First thing I look for is a GCF. There is no GCF, but then I can use my organizational x. To factor this, I need two numbers that multiply to give me 9, and they had to give me negative 10. Negative 9 times negative 1, lead coefficient is 1. So this does not factor to x minus 1. It's x squared minus 1 and x squared minus 9. All right, now I can set each factor equal to 0 and solve. You can keep factoring, but I know how to solve x squared minus 9 equals 0. So I'm going to do x squared minus 9 equals 0, and x squared minus 1 equals 0. Add 9, x squared equals 9, square root plus or minus, square root plus or minus, and I get two x values from this, 3 and negative 3. Here, x squared equals 1, square root plus or minus, and I get two more values, x equals positive and negative 1. So I have 4 x values. X equals 3, x equals negative 3, x equals 1, and x equals negative 1. So I need to know what my y values are. I'm going to plug in 3. I like to use this because it's the easiest math here. So I'm going to do y equals 3 divided by, plug in 3, y equals 1. So my first solution is 3, 1. Y equals 3 divided by negative 3. Y equals negative 1. So 3, negative 1. Y equals 3 divided by 1. So y equals 3. So 1, 3. And finally, y equals 3 divided by negative 1. Y equals negative 3. So negative 1, negative 3. And there's my 4 solutions. All right, last one. How do I solve it? Substitution or elimination? There's an x squared in the first one. There's an x squared in the second one. So I'm going to use elimination since they're both quadratics. I want to eliminate either the x squared or the y squared because there's one of each in each equation. So you just have to decide which one you want to do. It doesn't matter. If I combine them right now, nothing will cancel out. But I'm going to multiply the second equation by negative 4, and then the x squareds will cancel out. So I have 4x squared plus 9y squared equals 36. That's just me copying down the first one. And then distribute a negative 4 to the second one. Negative 4x squared minus 4y squared equals negative 16. Combine these. This cancels. 5y squared is equal to 20. Divide both sides by 5 so that you can square root to solve. Y squared equals 4. And then square root to solve. Square root plus or minus. Square root plus or minus. I have y is positive and negative 2. So I'm going to organize this. Y is 2. Y equals negative 2. It doesn't matter which one you plug it into. I'm going to plug it into this one because it just looks easier, right? It doesn't have coefficients. So I'm going to do x squared plus 2 squared equals 4. X squared plus 4 equals 4. X squared equals 0. Square root plus or minus, and I get 0. So 0, 2 is one solution. And I'm going to plug in negative 2. X squared plus negative 2 squared equals 4. X squared plus 4 equals 4. And notice you're going to get the same thing. X squared equals 0, x equals 0. So you get 0, negative 2. And there are your two solutions.